Okay, so we start with the next example. So now before, we talk about integers, but now things can get complicated. So we try to represent real numbers on the computer. So if you want to represent a real numbers on the computers, then there's 3 parameters you have to watch. First is the P, and P is like the number of digits, and Emax is like the maximal power, and Emin is the minimum power. So a floating point number in this system can be represented by plus or minus, and then because it's a normalized number, so we can have the first digit has to be the first digit has to be 1, yeah, and then the second digit will be D1 and D2, yeah, up to DP. So in our case, because P equals 2, so actually we have only D1 and D2, okay? And then, there's a power, so we take this one, we multiply by the power, so the power is E, and E is between Emin and Emax. Okay, so in our case, we have only 2 digits, so it will be 1 dot D1 D2 times to the E, and now E will be between Emin is -1 and Emax is 2 in our case. So how many numbers you can represent by these 3 parameters? So now suppose I plug in like D1 is 0, 0, yeah, and then you have, so remember this one is base 2, yeah, so base 2. So you can have either 0, 0, so the first possibility, and Emin, so it could be e to the -1, yeah, so this is the first number, what is the smallest number, and then you switch to the you turn on the last bit, so you can have 1.01 and keep the power still the same. So how many possibilities we can have? So we have 0, 0 here, 0, 1 here, then 1, 0, and 1, 1, and the power is still -1, yeah. And you can do the same for power 2 to the 0, because you can have 2 to the 0. Okay, so 2 to the 0, 2 to the 0 here, 2 to the 0 here, and then you increase the power 2 to the 1, yeah, so you have 1, 0, 0, and then 1, 0, 1, so everything here is binary digits, okay, so to the 1, and the last power is 2 to the 2, so you have 2 to the 2 here, 2 to the 2, so 1.10, 2 to the 2, 1.11, 2 to the 2. So you see, the first digit is always equal 1, because this one we call it a normalized number. So normalized number, the first digit is always equal 1, but we never store the first digits. We store only the digits after the dots, and we store the power, yeah. So you see there are 16, so there are 16 positive number. So there are 16 positive number.
Sorry, that's
Outside, huh?
yeah.
Okay, so maybe let me write down here, yeah? So,
Just
so you can see from the list here, we have 16 positive number. Okay, and similarly, if you change the sign, you see, remember this is a plus, so you can have another 16 negative number. 16 negative number. So you just use the same values here, but you just change the sign, yeah? So minus, minus, minus. Then you have all the numbers in this system. So you can see that MATLAB use exactly the same floating point number system, the same ideas. However, in MATLAB, the P here is 52. So you have 52 digits, okay? And the power E mean. So here you have minus 1, but in MATLAB, it will be negative 1022, okay? And the maximum power here is only 2, but here the maximum power in MATLAB can be 1023, okay? So now there is three important constants we need to know from the system. One is epsilon, one is real mean, and one is real max. So what is epsilon? So epsilon is the smallest. So epsilon is the smallest machine number, so that 1 plus epsilon is bigger than 1. So that 1 plus epsilon is bigger than 1. Yeah. So you see that in this system, right? So your number 1 is here. So this is your number 1. So 1 is just equal 1.002 to the 0. Okay. And then you turn the last digits to 1, yeah? Then you got 1 plus epsilon. So therefore, epsilon in this case is just 2 to the minus 2. Okay? So what is 2 to the minus p? Okay? And so the same in MATLAB. So in MATLAB, you know, like you describe the number 1 by 52 digits. Okay? And 52 digits here, all of them are just equal zeros. So 1 plus epsilon, you just turn on the last digits to 1. Okay? So therefore, epsilon in this case will be 2 to the minus 52. And if you try to evaluate in a floating point system, it will be about 2.2 times 10 to the minus 16. Okay? So this is exact value, and this one is when you plug in the calculator that gives you this value. And then another three constants are real mean and real max. So what is real mean? So real mean will be the smallest normalized machine number. So you see here, so the first digit has to be 1 because it's a normalized number. So all the other digits are 0. And then the power has to be at E mean. So E mean in our case will be minus 1. So then this one just gives you 1/2. Okay. So in MATLAB, so you have real mean is 1 because it's a normalized number. The first digit is 1, and all other digits are equal 0. So 52 digits. And the power has to be E mean. So in our case, E mean is minus 1022. Okay, and you can plug it in MATLAB to see what number you get, and you can type in real mean in MATLAB, and you can get the same number. Okay, so we've talked about epsilon and real mean. So then what is real max? So real max is when you turn on all the digits, right? So the first digit is 1, but now all the digits here is 1 as well. And you turn on the power to be the maximal power. So more or less, real max is the maximal machine numbers you can represent using a floating point number system. And now, so suppose in our small system, when p equal 2, yeah, and so when p equal 2, real max, it just equal 1.11 because you have only 2 digits here. And E max, in our case, it just equal 2. And so this number is just 1 plus 1/2 plus 1/4 times 4. Yeah. And it just gives you 4 plus 2 plus 1, what it just equals 7. Okay. But in MATLAB, p equal 52. So real max will be, you use the same techniques here. So it will be 1 plus 1/2 plus 1/4 plus up to 1 over 2 to the p. Yeah. And have to multiply by E max. Okay. And because in our case, p is 52, so I replace this one by 52. And E max is 1023, so I replace this one by 1023. 1023, yeah. So here I have to sum up this geometric series, and this one will be 1 minus 2 to the minus 53, 1 minus 1/2, okay, multiplied by 2 to the power 1023. And so this one will be 2 times 2 to the minus 52 times 2 to the power 1023. Okay, so this is a big number. So you can type in MATLAB to get out the constant here. But this is the maximal machine number, maximal real numbers that you can represent using MATLAB. Okay, so we've done